Dear students, I am Nilanjana Sanyalan, online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now we are solving questions on binomial expansion where the power is a rational number. In our previous session, we had solved two questions, and in one of the questions the power was a negative integer, and in the second question it was a fraction. And in both the questions the binomial expression was of the type a plus bx, where a and b are constants. Throughout our video sessions where we will be having the binomial expansion with the power as a rational number, we will be taking the binomial expressions to be of the type a plus bx. Okay? So, in our today's session, we will be taking the same type of binomial expression a plus bx, but in our previous session the a value was equal to 1. But in our today's session, the a value will be some other number but will not be equal to 1. Okay? So let's start with our today's session. The first question, it has two subparts. It says write down, the first subpart says write down the first 4 terms of the binomial expansion of 1 over under root 4 minus x. And the subpart B says use the expansion to estimate 1 over under root 3.6. We had estimated one more fraction in our previous session rather, and in our today's session again we are having a similar question. It is asking us to estimate 1 over under root 3.6 using this binomial expansion. So let's start with our answer. The first subpart A, it is 1 over under root 4 minus x. This can be written as under root if changed to indices will be half. So it will be 4 minus x raised to the power of negative half. Okay? Because for binomial expansions we need the power, not the surd form. Okay? So it is 4 minus x raised to the power of negative half. And what was the expansion? It was a plus bx raised to the power of n, was first of all written as a to the power of n times 1 plus b over a times x whole raised to the power of n. I had shown you how to get to this form from this form. You take out this a as the common factor between these two factors and it becomes a times, within parenthesis you have this part 1 plus b over a times x, and the whole thing is getting raised to the power of n. If we separate the two factors, they become a to the power of n multiplied by 1 plus b over a times x whole raised to the power of n. Okay? So a raised to the power of n will be staying and it will be getting multiplied with every term of this expansion. And since n belongs to the set of rational numbers, this will be an infinite series. So this was equal to a raised to the power of n, and sigma r is equal to 0 to infinity in CR and since the first term is 1, we just ignored that part. It is b over a times x raised to the power of r. So this is the binomial expansion total, and it is an infinite series, so they are asking us to give the first 4 terms of this infinite series. Okay, so first thing that we have to do is, you just see the expression, binomial expression, it is a plus b times x. If we relate this a plus b times x to 4 minus x, what do we have as the values of a and b? We see a is equal to 4 and b is equal to -1. Okay, so first thing that we have to do is we have to rewrite this expression in this form. Okay, so let us do that. So this is equal to a raised to the power of n. A is 4. So 4 raised to the power of -12, and it will be 1 plus, it is -1, so b is -1, so I am writing minus. So 1 over b over a. So a is 4, so it is 1 minus 1 over 4 times x raised to the power of -12. Okay, and now we will be doing the binomial expansion of this part. And 2, this is, okay, let me write this. This 4 can be written as 2 square, and this is -12. Okay, now coming to the binomial expansion. The first term will be having r value as 0, and in C 0 is always equal to 1, and b over a is -1 over 4 times x whole raised to the power of 0 is also equal to 1. So 1 times 1 is 1, therefore the first term of the expansion is 1. Second term of the expansion will be in C1. So plus r is equal to 1, therefore the denominator will be having 1 factorial. Okay, and the numerator, since the r value is equal to 1, we will be having a single factor in the numerator from NCR, and that will be the value of n. The value of n is equal to -12, so it is -12, and times b over 8 times x raised to the power of 1. So it is times -1 over 4 x. Okay, so this is the second term. Third term, it is in C2, therefore the denominator is 2 factorial, and since r value is equal to 2, we will be having 2 factors from in the numerator from this NCR. The first one will be n, which is equal to -12, and the second factor will be n minus 1, which is -12, -1, and then b over a times x whole raised to the power of 2. So it is -1 over 4 times x raised to the power of 2. This is the third term. The fourth term is (3 factorial), and now we will be having 3 factors in the numerator. It is -12, -12 minus 1, and -12 minus 2. Okay, and it is -1 over 4 times x raised to the power of 3. Okay, and it is actually an infinite series. We are required to give the first 4 terms, so I have written the first 4 terms. Okay, and then we can do the simplification. 2 square and 2 times negative half will be 2 to the power of negative 1, which is equal to half. Okay. And then it is, we come to the expansion part. 1 plus, we are having minus and minus, so it will be a positive term. So it will be half times 1 over 4 is equal to 1 over 8. So it is 1 over 8 x. Okay. Plus, this one is negative and this one is negative, so this is a positive term. And this is negative 1 over 4 getting squared, so this will also be a positive term. So it is a plus sign. And this is negative half, this is negative 3 over 2. Negative half, negative 1 is negative 3 over 2. Negative 3 over 2 times half is, negative half is 3 over 4. So it is 3 over 4 times 1 over factorial 2 is 1 over 2 times, this is 1 over 16. So it is 1 over 16 x squared. Okay. And then the fourth term, it is over here minus, minus, minus. So these three minuses multiplied together will be giving a negative product. And from this part also there is this minus sign raised to the power of 3. This will also be giving us a minus, a negative product. Okay. So there will be effectively 4 minuses getting multiplied. So ultimately the product, the final product will be a positive one. Okay. So first of all, let me write the factorial part. 3 factorial is 1 over 6. Then it is 1 over 2. This is, let me write them. 1 over 2, then it is 3 over 2. And then this one was, this is 2. So it can be thought of as 4 over 2. So it is 5 over 2. And that one is 1 over 4 to the power of 3 is 1, 4 times 4 is 16 times 4 is 64. So 64 x to the power of 3 plus dot dot dot. Okay. So now we can open the bracket. Half times 1 is half, plus half times 1 over 8 is 1 over 16 x, and then what is it? It is 2 times 2 is 4, 4 times 4 is 16, so it is 16 squared. Okay. So 16 square, 256. So it is plus 3 over 256 times 2. No, I have taken the 2, sorry. So it is 3 over 256 x square plus the numerator is 15. And can we cancel something? Yes, we can. So these two get cancelled. So the numerator will be 5. And we are having 1, 2, 3, 4, and this is the fifth 2. So 2 to the power of 5 is equal to 32. And 32 times 64. So 32 times 64 is equal to 120. Sorry, that's why I was wondering that how am I getting such a small number, 32 times 64, 2048, okay. So it is 5 over 2048 x to the power of 3 plus dot dot dot. So these are the first 4 terms of this infinite series, okay. So this was the answer for the first subpart. The second subpart, use the expansion to estimate 1 over under root 3.6. So we had 1 over under root 4 minus x. So let me just write the question once more. The expansion was for 1 over under root 4 minus x. And now they are asking us to evaluate or estimate 1 over under root 3.6 using this expansion. So we have to write this 3.6 in this form, 4 minus x. So this can be written as 1 over under root 4 minus 0.4, because 4 minus 0.4 is equal to 3.6. Okay. So we have seen the expansion of 1 over under root 4 minus x. This is the expansion. And now we are asked to give the value of this using the expansion. So we are seeing it is 4 minus 0.4. Therefore, x value is equal to 0.4. Okay. So we will be just substituting 0.4 in the place wherever we are having x, we will be substituting 0.4 and we will be getting the answer. Okay. So half remains, so let us write this, 1 over under root 3.6 is approximately equal to half plus 1 over 16 times 0.4 plus 3 over 256 times 0.4 square plus 5 over 2048 times 0.4 raised to the power of 3. And let us see what value do we get using the calculator, of course. Okay. So it is half, then plus 1 over 16 times 0.4. Okay, 1 divided by 16 times 0.4 plus 3 over 256 times 0.4 whole square. 3 divided by 256 times 0.4 square, okay, plus 5 over 2048 times 0.4 to the power of 3. 5 over 2048 times 0.4 to the power of 3. Okay. So what is the answer? It is 0.52703 0.527 0, 3, 1, 2, 5. Okay, 0.5270, let me write first. So 0.5270 and 3125. 3125. So 1 over under root 3.6 is almost equal to 0.52703125 using the expansion. And let us see what is the answer if we just take this, directly feed this into the calculator. What do we get as the answer? 1 divided by under root 3.6. Okay, so sorry, it is, don't have any, yeah. Zero 0.52704,628. You see, 0.5270 up to 4 decimal digits, they have the same figures, and after that it is 3 and this is 4. So they are very close to each other. Okay, therefore we are seeing, and obviously the accuracy will be increasing as we take more number of terms. We have taken only the first 4 terms. Okay, so the accuracy will definitely be increasing if instead of first 4 terms, if we take say 6 terms, definitely the accuracy will be more. Okay, so this was the answer for the 1 over under root 3.6 using the binomial expansion. Let us move on to the next question. This is also having 2 subparts. Find the first 3 terms of the binomial expansion of 8 minus 3x. Over here, both A and B both are having some value apart from 1. Okay, fine. And the power will be 1 over 3. Fine. So, and the second part is find the value. So, it is the interval of convergence. So, let's start with our answer. So, 8 minus 3x raised to the power of 1 over 3. Okay, and A is equal to 8, B is equal to negative 3. So, what will this be equal to? 8 to the power of 1 over 3 times 1 minus 3 over 8 x to the power of 1 over 3. Okay, and now we have to expand this part, and 8 is 2 cube, 2 cube times 1 over 3 is 2. So, I will be writing only 2 for this part. Okay. So, this will be 2 and then it will be in C0, first 3 terms, only the 3 terms we have to give. So, in C0 is 1, whatever may be the value of n, it is always equal to 1. And then it will be b over a is negative 3 over 8 times x raised to the power of 0 because r is equal to 0. So, that is the first term is equal to 1. Second term in C1, r is equal to 1. Therefore, the denominator is 1 factorial. And since the r value is equal to 1, you will be having only a single factor in the numerator which will be equal to n, which is 1 over 3 and multiplied by b over a times x raised to the power of 1. So, it is negative 3 over 8 times x. Okay. This is the second term. What is the third term? 2 factorial. r value equal to 2 in C2, so it is 2 factorial in the denominator, and since r is equal to 2, we will be having 2 factors in the numerator. The first factor is obviously equal to n, which is 1/3, and the second factor is n minus 1, so it is 1/3 minus 1. And that will be negative 3 over 8 x whole square. So these are the 3 terms, and it is an infinite series, so plus dot dot dot. So now we have to do the simplification. The first term is 1, nothing more to be done to it. This one is 1 over 3 times negative 3 over 8x, and these two will be getting cancelled. Third term plus, let me write the denominator first of all. It is half, and then it is 1/3, and 1/3 minus 1 is minus 2/3. And this is minus 3 whole square is 9, 8 square is 64, x square, okay? And this is the thing. So, and what can be cancelled? These two can get cancelled, and these two will be getting cancelled, okay? So it is 2 times 1 is 2, and then it is a negative number, so it is negative, and 1 over 4 times x, and then it is this is negative, right? So it will be negative. And this is 2 in the numerator, this is 64 in the denominator, so you don't have anything in the numerator. So numerator is 1, and it is 32 in the denominator. 1 over 32 x square, okay? And of course, it is an infinite series. We have given only the first 3 terms, okay? And then they are asking about, this was the answer for the subpart A, and for the subpart B, find the values of x for which the expansion converges. And we had seen the expansion converges when x lies between negative a over b to a over b. So x should be greater than negative a over b and should be less than a over b. In case you do not know why am I writing this relation, you please watch my previous video. Over there I have explained in detail, okay? And we know the values of a and b. They are a equal to 8 and b equal to negative 3. So the range of values will be x should be greater than negative a over b. This is actually the absolute values. So it is 8 over negative 3. The absolute value will be 8 over 3. That is, x should be greater than negative 8 over 3 and should be less than positive 8 over 3. This is the interval of convergence. X can have any value between negative 8 over 3 and positive 8 over 3. Okay? So we have answered the second subpart, the subpart B as well. And this brings us to the end of this session. So students, let us stop over here for today. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. So bye for now.